Oh my god. We're fucked.
So you know how I bought those dog toys?
We're so fucked. Oh, Jesus. Oh, it's gonna be a long day. Wow. You know what?
Hey girl, your mic's
No,
on, by
no,
the
I
way.
will just cover the 16 today, and if we have time, then we will start the 17th. But yeah, yes. Yes, actually, we didn't even cover the chapter 16.1 in the previous one, so I will cover it more. And so I plan to just finish 16 today.
Can you share the screen?
Okay. Okay, howdy everyone. So, okay, so today you know that we will have a quiz, right? So in this quiz, at this time, this quiz will be delivered in the eCampus, not the WebAssign. So,
Can you please share the screen?
okay, so you need to go to the web eCampus instead of WebAssign to take the quiz. Sorry. Okay, and the one other thing. Can you hear me or?
Can you share the screen?
Okay. Oh, I will share screen. Sorry. Yeah. Oh, just give me a second. Make it as your host. What is the? Okay, then I share screen. Oh no, not this one. Okay, got it. Now good. So yeah, so I said that. So today is, what is today? October 22. So quiz will be on eCampus and starting from 2:45 p.m. to the end of the day, 11:59 p.m. And if we do not get full credit on this quiz, it won't count against us, right? So it's just to help our exam grade, yes. So even if you didn't get any points from the quiz, then what you will get is just, it doesn't count it as a 0 on quiz, but it is just counted as 0 on bonus point on the exam. So your exam score not change it, but you just, lose the chance, right? That's all. Thank you. And this is the quiz for this week. And next week, we will have quiz for video, right? And at this week, I will actually give you a special kind of quiz, which came from the interview question from Accenture. Actually, yeah, one of my friends is now working on the investment bank, and he's got his job on 2010. So don't look at me as an old person, but anyway, so my friend got the job in the 2010 and he got some great question, which is related to chapter 17. So I will just give you the interview quiz for here. And next quiz, the reason I especially announced the quiz next week is that you can work together, which means that yeah, I will just introduce the problem, the quiz, maybe in the tomorrow, and you need to take your video until the next Thursday night. And when you serve the quiz, you can just ask your fellow students in the class, but don't Google it, please. Yeah, to serve the quiz. So yeah, and all you need to do on the video when you just get help from other is that just says that I've got some help from some friends here, or I've got it is joint work with someone blah 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 or something like that. So what you need to do is please must mention the credit from other. Right? So if you just follow this rule, then you are fine to get help from other students. And actually, I encourage you to get help because it's a little bit tough question. So if you are, if you're familiar with this chapter, then you are fine. But yeah, even in my case, I try to answer it in 3 days to answer the correct question. So don't worry too much about the correct answer, but instead just work with your friends and figure out then how can you solve this problem, right? So it's a little bit tough, but it's not that tough, right? So yeah. And also, does anyone have group sharing? Yeah, so I've heard that from the people who made a group chat for this class. And yeah, I encourage you to join the group chat and please talk with others to discuss about this quiz, right? And yeah, I will send it more detailed announcement in the tomorrow with the problem, right? So yeah, so here Chelnum, I will just, can I share this group meeting? So here, yeah, for the people in the classroom, group meeting is https groupme.com and join group /6181335 09 GT4. Yeah, here case sensitive, so O should be small o. GT4 and small x W. Yeah, that's right. So this O and X are lowercase letter, but all other is uppercases. So yeah, so please discuss it with your friends in the class for this quiz. And the password for today's quiz is honor because we use Honor. So it is 5 lowercase letter. Yeah. So if you don't want to use Honor, then please let me know via email. Then I will give you the link for WebAssign for you so that you can test it, right? Okay, so I will send you an email, but just please email me reminder for sending you a quiz. And the video quiz is for next week, right? So it is not for today. So this is for today, and this is for next week. this is for next. Okay, do you have any other question? Good. Okay, and I don't know who are not in here. Okay, I will just mute everyone, so except me. So you are fine. Okay, got it. Is it good for Zoom people? You don't hear any, Great, yes. Okay, then let's finish the chapter 16, and if possible, then we can just do chapter 17. So, okay, so what we deal with in the previous lecture is that how to find the cases when the scheme, grade and this check digit scheme does not distinguish the buried code and the error code, right? So these are all the examples. So let's deal with this example 1.8. And let the check digit is given by this A4 is equal to 4A1 plus 7A2 plus 2A3 mod 10. And will this catch the transposition errors of the first one and second digit? So in this case, correct code is A1, A2, A3, and A4. But transposition error happens from first and second digit. So incorrect code will be A2, A1, A3, A4, right? So in that case, check digit for correct code is 4 times A1 plus 7A2 plus 2A3 more 10. And check digit for incorrect code is 4 times A2 because someone who put A2 instead of A1 for the first position. And he or she also put A1 into second position instead of first position. So it should be 7A1 plus 2A3 more 10. So if this can catch the error of transposition, it means that the check digits for correct code and incorrect code will be different, right? But the error will not be caught if the check digits are the same. So i.e. if this number for A1 plus 7A2 plus 2A3 minus 4A2 plus 7A1 plus 2A3 is a multiple of 10, right? If their remainder over 10 is the same, then we cannot distinguish check digits, so we cannot count the error. Does it make sense? Or do you have any question? Yeah, good, okay, thank you. Then you can simplify this equation. First of all, what you can find is that these 2A3 are repeated and have minus sign, so you can just cancel out. So first of all, what you can get is 4A1 plus 7A2 minus 4A2 plus minus 7A1 is multiple of 10. And next, you can see that 7A2 minus 4A2 is just 3A2, right? So you can write down it as 4A1 plus 3A2 minus 7A1 is multiple of 10. And next, you can actually simplify this 4A1 minus 7A1 into minus 3A1, right? Because you can just add them together to get minus 3A1 plus 3A2 is multiple of 10. And lastly, you can just put 3 together from the factors to get the minus 3 times A1, oh, sorry, 3 times A1. Okay, so it's 3 times A2 minus A1, or you can just write down minus A1 plus A2, it is your choice, is a multiple of 10. Right? Does it make sense? Good. Okay. So here we cannot clear this 3 because 10 is not divisible by 3, right? So we cannot do anything on here. But what we need to know is that actually, yeah, if A2 minus A1, so it means that A2 minus A1 should be multiple of 10, right? Because even if we just delete 3, it means that, yeah, to make this whole number as a multiple of 10, A2 minus A1 should be a multiple of 10, right? So in that case, you can just delete this 3 here, but not in here. Does it make sense? I think it's a little bit tricky. So if you have any question, please let me know. Oh, there is a question. How come it become minus 3A1, minus 3A2? What did you do to the 4 and 7? So what I did is this 7A2 minus 4A2 first to get plus 3A2 here. And then next, what I do is just this 4A1 minus 7A1 to get minus 3A1. Does it make sense, David? Okay, yeah. And lastly, what I did, okay, so I will just write down it more clear. Yeah. And what I did here is just taking 3 outside of the factor to get 3 times A2 minus A1 is multiple of 10. And in here, you can delete 3 because if 3 times something is multiple of 10, then that something should be multiple of 10, right? If it is not a multiple of 10, then 3 times something cannot be multiple of 10 because 3 is not the factor of 10, right? Only 2 and 5 are factor. So that's why I can just delete this 3 from here that just say that error will not be counted if A2 minus A1 is multiple of 10, right? Because 3 is not a factor of 10, we can ignore it. Does it make sense? Or do you have any question? Mm-hmm. Mm-hmm. Yes. No, in case of 4, you cannot delete it, but instead you can just divide it both by 2 to get 2 times something is multiple of 5. Because 4 has also factor 2, right? But in case of 6, so 6 has also factor 2 because 6 is 2 times 3. So in that case, you can get 3 times something is multiple of 5. Yeah, but 7, yeah, you can just ignore it. Yes, that's a good question. Pardon? Oh, yes. So 3 or negative 3 is not important. The sign is not important because, you know, in that case, what I actually did is just change the position of A2 and A1 to get just positive 3, right? But even if it is negative 3, you can do the same thing. Good. So error will not be caught. So the Morgan says that so error would be caught. So Yeah, error will not be caught if A2 minus A1 is your multiple of 10, right? Because, yeah, so in case of 3, okay. Mm-hmm. 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 Yes, that's correct. Yeah. So yeah, that's what Abir and Grace actually ask us. So okay, see ya. Oh, do you have a question? So in case of 7, so if it's 7 times A2 minus A1 is multiple of 10, it is the same as A2 minus A1 is multiple of 10. So you can just ignore 7 because 7 is not a factor of 10. Good? Does it make sense? So if two numbers share the factor in, so I will just write down it here. If two numbers, so let's say, okay, let's say just examples. Example 1, in case of 6 times A1 minus A2 is multiple of 10, then 6, 10 shares 2 as factor. So in that case, this is the same as 3 times A1 minus A2 is multiple of 10, multiple of 5. And again, here's 3 and 5 does not share a factor because they are prime. So in this case, you can also one more reduce to get A1 minus A2 is multiple of 5. Right? That's the case of 6. But let's deal with the case of 2. So in case of 7, 7 A1 minus A2 is multiple of 10. But here you can see that 7 and 10 doesn't share any factor, right? Because 10 is 2 times 5. But 7, you cannot make 7 from 2 times something, or you cannot make 7 from 5 times something, right? So 7 and 10 does not share factors. So in this case, you can just ignore it. So A1 minus A2 is multiple of 10. And there are questions from Zoom that Morgan that, but with the example, if we kept 3, so you can keep 3, but the reason I just want to delete 3 is that to reduce the case numbers, right? Because if you use 3, then what you need to consider is not from 1 to 9, but from 1 to 27, because we just multiply 3 for each member, right? So that's why I want to delete this 3. Does it make sense, Morgan? Okay. Great. Yeah. Do you have any other question for this? So I have a question for you. So in your high school, did you learn about the greatest common denominator or least common multiple? Oh, great. Then it is determined by actually greatest common denominator. So for example, in this case, GCD of 6 and 10 is 2, which is greater than 1, right? Then you can just divide both sides, this coefficient and this one, right? But if your GCD, greatest common denominator, 3 and 5 is equal to 1, then you can just ignore this part, right? So that's the simple rule. Oh, great. Yeah. So Dawson asked me a question that what is the case if 3A1 minus A2 is multiple of 5 or multiple of 9? So in this case, again, what is GCD of 3 and 9? greatest common denominator of 3 and 9 is 3, right? Because both are divisible by 3. So it is 3. So in this case, you can just divide this number by 3 and divide this number by 3. So what you can get is A1 minus A2 is multiple of 3. Good. Does it make sense, Dawson? Great. Yeah. So go back to our example. So here we can say that error will not be caught if A2 minus A1 is a multiple of 10, right? And the integer multiple of 10 here, oh, I need to see my answers because to check that, yeah. Because I'm not good at, calculating in front of the audience, so I just want to check my answer again to check it. Where? Oh, here. So this is a multiple of 10, but the integer multiple of 10, integer multiples of between 1 and 9, non-exist, right? Because of 10 between 1 and 9, so from, like, if you think about multiples of 10, then it is just 0, 10, 20, 30, 40, but none of them is not inside of 1 and 9, right? It means that you cannot have some number which is multiple of 10 by subtracting some one-digit number to one-digit number, right? So in conclusion, so all transposition errors of the first and second digits will be caught, right? Because there are no cases of A2 minus A1 is multiple of 10. And in this conclusion, what actually assume is that A2 is different with A1, right? So, in case of A2, if A2 is equal to A1, then transposition error is actually not an error, right? Because it's the same. So this is our hidden assumption. Great. Do you have any question? Pardon? So all the errors will be caught is that, so think about the cases. So, okay. Yeah, I just counting this, actually I just thinking in my mind about this kind of table. So think about that this is for A1 and this is for A2, and A1 can be from 0, 1 to 3, 4, 5, 6, 7, 8, 9, because they are all one digit number. And A2 can be also 0, 1, 2, 3, 4, 5, 6, 8, 9. And if you think about A2 minus A1 for each one, then this one gives you 0. This one gives you -1 because 0 minus 1 is -1. So likewise, you can get -3, -4, -5, -6, -7, -8, -9. And likewise, for 1, you can just add one more number, right? So 1, 2, 3, 4, 5, 6, 8, 9. 5, 6, okay, I missed 7. 7, 8, 9, but again, this one goes to 9, 8, 7, 6, something. So all the numbers in the table should be one digit, right? With signs. But all multiples of 10 except 0 is 2 digit, right? So that's why we cannot have, some numbers with multiple of 10. So it means that there are all transpositions will be cut because there is no number with subtraction is multiple of 10. Okay. Yes, you're right. Great. Do you have any other question? Okay, I checked the Zoom. Okay, great. So, what I said, what Abir says is that, yeah, if it is multiple 10, it is a multiple minus 10, right? Yeah, because of range, yes. Okay. Does it answer your question, actually? Okay. So I will repeat the question if I got the question, sorry. Okay. Yeah. Okay, then let's deal with the next one, example 1.9. So let's check digit A4 is equal to this 5A1, 3A2, A3, mod 6. And we want to figure out whether this catch the transposition error from second and third digit. So in this case, correct code is, as usual, A1, A2, A3, A4. And the incorrect code, now transposition error happens from second and third digit. So it should be A1, A3 instead of A2, and A2 instead of A3, A4. So check digit for the correct code is 5A1 plus 3A2 plus 8A3 mod 6. But check digit for incorrect code is A1 is the same, but now we just put A2 on the second position, no, A3 on the second position. So this one should be 3A3. And we put A2 into the third position. So this will be calculated as A times A2 and mod 6. So the error will not be caught if the check digits are the same, i.e. if 5A1 plus 3A2 plus 8A3, which is just check digit for correct code, minus check digit for incorrect code, which is 5A1, 3A3 plus 8A2 is your multiple of 6. Then you can simplify this equation. First of all, this 5A1 are repeated and have a negative sign, so you can cancel it to get 3A2 plus 8A3 minus 3A3 minus 8A2 is your multiple of 6. Then 8A3 minus 3A3 is 5A3. So what you can get is, I just write down 5A3 first. 5A3 and the remaining term plus 3A2 minus 8A2 is multiple of 6. Then next, 3A2 minus 8A2 is 5 minus 5A2, right? So it is 5A3 minus 5A2 is multiple of 6. And we know that, okay, you can factor out, oh, sorry, how can I? You can factor out this A3 and A2, 5A3 minus 5A2 by 5. Okay. 5 times A3 minus A2 is multiple of 6. And lastly, we know that greatest common denominator of 5 and 6 is 1 because 5 is just 5, but 6 is 2 times 3. But you cannot make 5 by multiplying 2 to something or 3 to something, right? So that's why we can ignore this 5 and to just conclude that the error will not be caught if A3 minus A2 is your multiple of 6. Yeah, could you do minus 5A2 plus 5A3 instead of 5A3 minus 5A2? Yes, you can do that. So yeah, you can just put this one first and put this A3 next. But I just change the position because I don't want to get signs from outside. So, but you can do that, Dawson. So what Dawson asks me that, yeah, actually you can write down it as minus 5A2 plus 5A3. But this is exactly same as this one. But yeah, so in that case, what you can get is 5 minus A2 plus A3. But yeah, this is just nothing but change of this position in here, right? Okay. Do you have any question on this procedure? Or? Good, thank you. Then, yeah, then what we need to find is just when this A3 minus A2 is a multiple of 6. And so integer multiples of 6 between 1 and 9 are 6, right? Because other than this, multiple of 6 is 6, 12, or 6, 0, minus 6, or something like that. So it should be 6. So conclusion is that if A3 is, 6, A2 is 0, then you can get 6, right? Likewise, if A3 is 7, A2 is 1, then you can get 6. A3 is 8, A2 is 2, you can get 6. A3 is 9, A2 is 3, you can get 6. So there are 4 cases for getting 6. And you also need to consider the getting minus 6, right? And this is nothing but interchanging two numbers, right? So it is just 0. A3 is 0 and A2 is 6. Then you can get negative 6. And likewise, 7, 1, 1, 2, 3, and 7, 8, 9. Then you can get negative 6 again. So 4 cases of getting negative 6. So here are 8 cases, and pairs are 6, 0, 7, 0, 1. Eight, 2, 9, 3, and 0, 6, 1, 7. So just transposition to number. Yeah. These are all possible cases that the error will not be caught. Right. Does it make sense, or do you have any question? Okay, so I will put this in 1.10 as your exercise because it is just nothing but just repeating the same thing on when we have some single digit error on the first position. So I will put it in the lecture note and we will go to the 16.2. So it is about the zip codes in the United States. So in case of United States, yeah, each state, yeah, there are 10 national regions. So it is actually including some, states. So for example, 7 is assigned to not only Texas, but also, yeah, Louisiana and Tennessee. Is it Tennessee, right? And Kentucky, maybe, right? I'm not good at US geometry, so okay.
Maybe
So
one
that
above
7 is assigned for 4 states, including Texas and Louisiana. And for example, 9 is actually shared with Washington, California, and Alaska and Hawaii. So those are numbers. Each number from 0 to 9 are each state assigned to some combination of states. And each state actually divided into the average of 10 smaller geographic areas. So it will be, yeah, so and they assign the 3-digit numbers for each areas. And the first and fifth digit identify the local delivery numbers. So for example, in case of Texas A&M zip code 77843, tells us that 778 is code for Bryan, and we know that Texas has 24 section families. You don't need to memorize it, but it is just for common sense. So, and 778 is for Bryan, and local delivery. So local delivery is just this 47 is for Texas A&M, and this 0001 optional, because even if you don't have this, you put 0001 on the zip code, and your email or your mail or your box will be delivered correctly, but it will be helpful for postman to identify eject mailbox, right? So all you need to do know about this section 2 is that the first 3 numbers actually called sectional numbers, and it is actually assigned for each section in the state. And also each section will be assigned, it will be decompose their areas into 10 areas. We're using 2-digit numbers, and it is called local delivery number. And the optional 4-digit in the outside is just used for postman, right? That's your for section 2. Okay, does it make sense? Postman. So what I mean is just people in the USPS. Yeah, okay. So in PS or FedEx or any delivery things, right? Okay, so this is some example of the identification code we can see in our usual, right? And let's deal with barcode. So a barcode is a system for representing data with only 2 symbols, each called binary system. So you can see that this is 0 and 1 can represent all the numbers. So yeah, and for example, if you want to make 2 as representing 0 and 1, you can put it as 1, 0. So okay, I will just give you just general example. So for each position, you can put 0 or 1 in here. Okay. So let's delete, okay, some example number. 0, 1, 0, 0, 1, 1. Then each position, for example, this is position for 1, and this is position for 2. This is position for 2 to the 2, which is 4. And this is for 2 to the 3. And this is for 2 to the 4. And this is 2 to the 5. So this is called binary system because this number 110010 is actually denote the 1 times 2 to the 5 plus 1 times 2 to the 4 plus 0 times 2 to the 3 plus 0 times 2 to the 2 plus 1 times 2 to the 1, which is just 2, and 0 times 1, and which is 32 plus 16 plus 2, 48, 50. Right? So the binary system is, yeah, so in usual, our decimal system, so for example, yeah, 15608 means that it is just 5 times 10 to the 3 plus 6 times 10 to the 2 plus 0 times 10 plus 8 times 1, right? So that's usual decimal system. That's why we call it as 5,000, 1,000, and 600, and 0, 10, and 8, right? That's why we call the number as using thousands and hundreds, because thousands is just another name for 10 to the 3, and 100 is another name for 10 to the 2, right? Pardon? Yes, we will always go from left to right in binary. So like the decimal number, right? So in the decimal number, the first digit should be in the right, and 10th digit should be in the second. Likewise, binary. In case of binary, we should write down in that order. Great, yeah. So what Grace's question is that in case of binary number, we should write from right to the left. So yeah, so 00001 is nothing but just 1, right? Like, yeah, 0008 is nothing but 8 in the decimal. Likewise, it is just 1 in the binary, right? So binary is nothing but just change our 1,000 into 2 to the 3, and 100 into 2 to the 2, and 10 into 2, and 1 into 1, right? So 1 is the same, but for all other number, 10 to the something is changed to 2 to the something, right? So that's called binary. So you can make it not only binary, but ternary or some other numbers. So for example, yeah, but ternary will be explained later. But here, Barcodes just uses this binary system, right? And so, and yeah, so this barcode is your binary system that is made up of a series of dark bars and white space in the representing characters. And for example, here you can see it is just user barcode, right? And if you see the barcode in your receipt, then there is some long bars and there is some short bars here, right? So here long bar denotes 1 and short bar denotes 0, right? So for example, so I think so each so if this 5 number can denote 32 numbers, right? Because okay, 32 numbers, because this is 2 to the 1, so this is 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. No, sorry, 63 numbers, 64 numbers, because if you just add 2 to the 5 plus 2 to the 4 plus 2 to the 3 to 2 plus 1, then what you can get is actually 32 plus 16, 8 plus 4 plus 1, so it is 63. So that's why we use backward, because it is combinatorially represent numbers using which can be used for computer. And one of the example of backward is postnet code, which is used to encode G+ phone numbers. So each digit is represented by 5 vertical bars and 2 long and 3 short bars. So here there are only 2 long bars and 3 short bars, right? And this G+4 is followed by a check digit, which is determined by adding the first 9 digits and choosing the check digit. So the sum of the all 10 digits are multiple of 10, right? So the bars on for these 10 digits are surrounded by a Tor bar. So here is Tor bar, guard bar, on each end, and code guard bars to designing it beginning and end of code, right? So the start of code is started with Tor bar, and they give you, 5 bars for each digit. And then end of the session, they also give some Tor bar, which is called guard bar. So here, what you can get as your digit number is 60515 and 9968. So the check digit is 1. So if you just sum all the digits, plus 9 plus 9 plus 6 plus 8, then 6 plus 5 is 11, 1 plus 5 is 6, 9 plus 9 is 18, and 6 plus 8 is 14. So it is 11 plus 6 plus 18 plus 40, and 11 plus 6 is 17. 18 plus 14 is 32. So it is 49. And you know that 49 plus 1 is 50. So the check digit is correct, right? Because it makes us give just the 0, which is it makes us the multiple of 10, right? 0 as a remainder. Does it make sense? So it is just another example for barcode. Good. And the another example of a barcode is quick response code or QR code. So this is maybe you already know, especially if you use an Android phone, then you can use this QR code a lot, right? So, and if you actually, this is not just example, but it is just exact QR code. So for example, I cannot see my phone, but if you just take your phone and take a picture on this QR code, then it sends you to the Tamu homepage. So maybe you can try it. Okay, these are for binary code. Do you have any question? Sorry. Good, great. Yeah. Okay, then let's deal with the 6.4. So 6.4, we deal with about the personal data. So yeah, one of the other identification number is social security number. So if you already start your job, or if you are in the in United States, then you will have Social Security number, which is for your taxation object. And here, the first 3 digits tells the state and where the application was filled, and the other 3 and 4 digits are not known at this point. And maybe, yeah, NSA knows about this, but I don't know. So, and example 4.2 is about Florida's driver license. And here is some sample of Florida's driver license. And in this case, it has a form 4-digit number dash for 3-digit number dash. YY means just year, and DDD is some code, and N is the overflow digit. So so I will explain what it is. So here XXX, your first 7 digits is based on coding of your name. So your name will be turns out to be some 7-digit number using some procedure. And YY is just last 2 digits of the year of your birth. So in case of this, sample one, it is Joseph A's sample case. Yeah, his 30 means that it is 2 digits of your birth, so it may be 1930, right? This 30 is from 1930. So he is actually, year of birth is 1930. And DDD is coded from the month and day of your birth. So these 3 digits are, in case of male, it is 40 times M-1 plus D. And in case of female, it is 40 times M-1 plus D plus 500. So you can see that actually this M is not greater than 12, right? Because we have only 12 months in a year. So if you just multiply 12 with 40, then the maximum is 480, right? And that's the reason why they add 500 for some other, female. So in case of female, because they just want to distinguish from man and woman, right? Okay, question? 11 times 4?
Because you have 12 months
Mhm.
from the year, and then you're minus 50.
-1. Yeah, 11 times 40. Yes, you're right. Thank you, Grace. So what Grace pointed out is that actually what we can multiply is from 0 to 11 because we have -1 term. Okay, thank you. So yes, so in that case, and we have 30 days, right? So the maximum of this 40 times M-1 plus D is 40 times 12 minus 1 plus 31, because 31 is the last day of the month. So it is 440 plus, because it is 11 plus 31, so it is 471, right? So to distinguish man and woman, so they just add 500 so that the police or other officers can distinguish directly from driver license about the sex of the person, right? So that is the reason why they add 500. And this system, so this system uses 40 as a root representation for number of days in a month, right? And any run over 4 digit in case of multiple people have the same number. So some cases, yeah, there are some people whose date of birth is the same, right? And they just applied for the same driver license, then they just give some number for each person who applied, right? To distinguish them. So first question from here is that what are the range of values of DDD for male and for female? So here, the least number of male is that it is case when the date of birth is January 1, January 1st. January 1st. In this case, the number is the smallest because it is 40 times 1 minus 1 plus 1, right? Because we have no days start with 0. So 1 is the smallest one. So in this case, it's 1. And in case of DOB is December 31. Then it is 40 times 12 minus 1 for 31. And as we calculated here, it is 471. Oh, and Alexandra asks that, what does it say in front of the 30 by license? So you mean this 30? What 30 did you mean, Alexandra? 1A36, 1A30. In 9030. Sorry, it is not 1A30. So this is for, what this YY is for age, right? So it is 1930. It means that actually their year of birth is 1930 because, yeah, maybe it is not from 8030 or he's not from in the future 2030. So I think it is 1930. Yeah. Yeah.
I have a question.
So again, go back to this example. So the range of values of DDD for May is from 1 to 471. And then DDD for range of values of DDD for female is just 501 to 531, right? 931, 971, sorry, because we just add 5 to 400. So this is for men, for women. So, okay, male and female. Okay. Sorry. And Joanna asks me that why are there only 3 spots in the DDD? So because, yeah, DDD is 3-digit number, right? And from this formula, it already generates 3-digit numbers, right? So in case of 1, they just put it as 001, right? So that's the reason why they only have 3-digit, because 3-digit can represent every numbers from 1 to 471 and 501 to 971. Does it make sense? Great, yes. And next question is, are the digit YY DDD correct for Joe's sample? So let's see what is his YY and DDD. So his YY is 30 and his DDD is 761. So 30 indicates that, as I said earlier, so 30 indicates that his birth year is 9030, right? But again, here we have another information about DOB. When his DOB is July 11th, 1980. But his DOB is July 11th, 1980. So this is not correct YY, right? And for 761 indicates 40 times his birth month minus 1 plus birth date, right? But in case of his DOB, it is July 11th. So if you just calculate this number, but in his case, it is 40 times July means 7, so 7 minus 1 plus 11, and which is 40 times, 40 times 6 plus 11. So it is 240 plus 11, so it is 251. But his number is 761. So 761 is not correct number for this date of birth. Right? So both numbers, YY and DDD, are not correct. Okay, do you have any question? So in the section 4, yeah, you can use this scheme about the driver license number to indicate whether the given number is valid or not, or can you find some missing number from some driver license, right? Okay. Do you have any question? Great, then let's deal with some other examples. So determine the Florida's license number, YYDDD for female who was born on September 18, 1942. So here, YY is just 42, right? It is just nothing but last 2-digit number of the birth year. And here, month M is 9 because she was born on September. And date of birth is 8, so D should be 18. Then when you can get your DDD is 40 times 9 minus 1 plus 18. But she's a female, so you need to put 500 in here. So it is 40 times 8 plus 18 plus 500. So 320 plus 18 plus 500. So it is 838. So 838 is DDD and 42 is YY. So answer is 42 838. Is it good? Great. So, and next question is, what can you determine about a person who holds a private driver license with YYDDD as 61607? So here, YY is 61, means that this person definitely born in Florida in one of the 61, or or 1961, but cannot be 2061 because it's not in picture. And I think that Florida was not a state in 1861, right? I'm not sure, but yeah, I'm not sure about this date, but maybe it is not from 1861. So possible, choice is 1961. Maybe it is not Florida, but it is kind of Massachusetts or some other big old states. Then maybe it is possible, but no. So usually we can just infer that it is 1961. And from 607, which is DDD, then in that case, yeah, it is definitely greater than 500. So you can infer that the person is female, right? And another thing you need to know is that in that case, this DDD, this 607 is from 40 times months minus 1 plus day plus 500. So you can just subtract this 500 from both sides to get 107 is equal to 40 times n minus 1 plus some d, right? But here, one you can find is that actually this number is always multiple of 10, right? So it always gives you the 0 on your first digit, right? So your first digit is totally determined by this number d. So d should be 7 or 17 or 27, right? And since this whole number is less than 120, so m should be less than 2, right? 3, right? Because m is 4, then 4 minus 1 is 3, so 3 times 40 is 120. It exceeds the 107, right? So m should be from 0 to 3. But if m is 0, then you cannot make 107 from d because d is greater than, d is less than 31. So m cannot be 0 because d is less than 31. So you cannot make 107 from just d, right? And if m is 1, then you can make it difficult because even if m is, sorry, what I mentioned is m is 1 case, sorry. Definitely one starts with January. So, and in case of m is equal to 2, so in case of February, also you cannot make 107 because 2 minus 1 is just 1, and 1 times 40 is 40, but d can maximize on 31, but 40 plus 31 is less than 107, right? So this is also be possible because in that case it is 40 minus 1 plus d is less than 71. So in case of m is 3, then not possible. If m is 3, then it is 40 times 2 is 80. So 107 minus 80 is 27. So d should be 27, right? Then m should be 3. So this person, date of birth of this person is 1961 and March 27, right? And you can see that there are no other choices. If m is 4, then 3 times 40 is just 120, so you cannot make 107, and so on. Does it make sense? Okay. Do you have any question? Okay, so I'll just leave this, the next one also exercise, and I will just stop the class right now. And I just want, announcement is that, yeah, as I said in the last time, you don't need to memorize all the check digit number formulas. So here in the last page, you can see this summary of check digits, right? And I will provide it in the exam 3 in the a week after. So you don't need to memorize it, but just know that, yeah, maybe if you see it, but what I want you to do is just see these numbers at these formulas and you can solve the problems in the exam, then you are fine, right? Okay, so thank you very much. And the password is honor. And questions, how many questions in the quiz? I think it is 2 questions. Yeah, 2 questions, yes. 15 minutes. Yeah, but it's not that long. So it is just one question is from, finding some error. And the other question is from the number 8, which is similar to number 8 in the homework. So yeah, it is not the similar. Okay, question.
So I missed the beginning. Where is the quiz? Is it on eCampus or is it on?
Yeah, it will not be on the
website?
quiz. Yeah, so that last page is not will be on the quiz. So, and yeah, for each question in the quiz, I will just provide for each formula, so you don't need to memorize it or something like that. Yeah. And each quiz time, yes, quiz will take 15 minutes. And is the quiz over disturbed? Yes. Okay, and 2 questions. Yeah, each on eCampus. So quiz is on eCampus, not WebAssign. And if you don't want to use the eCampus for Honora, then please let me know by email. Then I will send you. I will let you take the quiz on the WebAssign, right? So maybe someone who worried about the kind of privacy issue on Honora, then you can send me an email, right? So only for people, Morgan. So only for people who don't want to use Honora, you can use it. You can take it on WebAssign, and please send the email in that case. Okay. Mm-hmm.
So the quiz is due by midnight or what time?
It's time from now to midnight. Yeah, you can take it in any time.
That's for homework.
Mm-hmm.
There's no like no thing to base. It's only this.
Yes, so you can actually, when you solve the homework, you can see the this formula sheet. So in case of rental car, the number found by the digit prior to check digit is mode 7. So in this case, the check digit is the last number. So if you just mode 7 for this first 5 number, then you can see whether it is valid or not. No problem. Okay, so when will the quiz will be ready for people that want it on WebAssign? Yeah, it will be when I just go to my house and I'll just send it to you. So yeah, so it will take, I think that you can serve it before the 3:15. So yeah, I will make it as soon as possible. Thank you. And yes, I will allow to use the note. Yes. Okay, is there any other question? Then I will stop the session. Please let me know if you have any question via email. Thank you.